All right, in this video, we're going to cover 1.3 and 1.4. Both sections are relatively short, and I think the video will be short as well, so you'll like that. So in 1.3, we're looking at frequency tables, and levels of measurement. So more vocab. I know it's more vocab. So after collecting data, it's often useful and informative to summarize our data by constructing what we call a frequency distribution. So let's kind of define some things. So frequency is the count. It's a count. That's all it is. It's a count of how many observations fall into a category. All right? Now, a frequency distribution is a listing of all categories along with their frequency. So have all the different possible answers and how many times do those answers happen. Okay? Frequency distributions can be used with both qualitative and quantitative data. The definitions below are used in discussing and constructing frequency distributions for quantitative. So we're going to focus on the quantitative. You can do it with qualitative, but we're going to focus on quantitative. All right, so the first calculation we can do is what's called a relative frequency. Okay, it's a proportion or a percent. So you just got to remember relative means percentage, okay, of the count in a category relative to the total numbers in all the categories. So here's what you're going to do. You're going to take that class frequency and divide it by all the counts. And I'll demonstrate this here on the next page. Now, a relative frequency distribution is a listing of all the categories along with all their relative frequencies. So it's all their percentages. The sum of all the relative frequencies must be 1, and that should make sense because if we're looking at all what percent is this, what percent is that, they all have to add up to 1. And then lastly is what we call a cumulative relative frequency. The sum of the frequencies for that class and all previous classes. So we accumulate to get to 100% by the end, okay? I'm going to demonstrate this for you, so don't worry, okay? So look, the table below lists the frequencies of the amount of cash each student has in his or her pocket. Use the frequency distribution table to construct the relative frequency distribution and the cumulative relative frequency distribution, okay? So here's our categories, right? $0 to $4, 5 to 9, 10 to 14, on and on and on, and how many students in each category, all right? So it's really, really simple. For the relative frequency, all I'm going to do is take how many students, let's see, how many students total are we talking here? We need to add them up. So if I add up, this is 8 plus 8 plus 6, 16 plus 6, 22, 32, 39. So there's 39 students total. So I'm just going to do the frequency. I'm going to do 5 out of 39. That gives me 0.128. So that's what I put for my relative frequency. And then I do 3 out of 39. When I do that in the calculator, I get 0.077. 8 out of 39. So again, it's percentages, right? I get 0.205. 6 out of 39 is 0.154. 10 out of 39 is 0.256. And then lastly, 7 out of 39 is 0.179. So cumulative means I'm adding them up. Add them up as you go, okay? Cumulative, well, the lowest category, there's only 5, right? So this stays always the same. So my second category down, there's 5 plus 3 gives me 8 out of 39, which we know is 0.205. Okay, this one, I take that 8. I'm just adding up my frequencies now. So I take those 8 that I just had, right? The 5 and 3 is 8. So I do 8 plus 8 gives me 16 out of 39. I need to find that value. That's 0.410. The next one down, I'm going to add 6 to 16, and that gives me 22 out of 39, which gives me 0.564. Okay, if I take the 22, I'm just adding now. I went 5, add 3, add 8, add 6. Now I'm adding 10. So this would be 32 out of 39, which is going to be 0.820. And then lastly, it should make sense. If I'm adding the last 7, that's 39 out of 39. That should be 1, right? And theoretically, it just adds up to 0.999. It should be really, really close to 1 if you have added them up correctly. Okay? Cumulative just means add them up. That's all it does. All right? That's 1.3. That's really all there is to it, is being able to take a distribution, create this table, and know what these terms mean. Remember, relative frequency is percentages, and cumulative relative frequency is you're just adding the percentages down. All right, in 1.4, it talks about experimental design and ethics. So we, again, have 2 types of variables we need to discuss. 2 more vocab words for you. The first one is an explanatory variable. The variable whose effect you want to study. It's the independent variable. And then you have the response variable. The variable that you suspect is affected by the other, okay? So if you're thinking algebraically and you have your 2 axes, here's your x-axis and your y-axis, right? Explanatory is your x, response is your y variable, okay? How do I remember that? Well, explanatory has an x in it, okay? It's almost like a cause and effect, but we know that one thing can't cause another right now. We're not using causation, remember from the previous video. The response variable is often considered the outcome of interest, but we think those outcomes may be influenced by the explanatory. Often the explanatory comes first in a time sequence. So when you're reading and you're not sure, go with the one that's first as explanatory. For example, how hard a golf ball is swung is used to determine how far it travels. Club head speed is the explanatory, and the distance the ball travels is the response variable. All right, so simple enough. Now, an experimental unit is a single object or individual that's measured. Okay, thinking in experiments, units are people sometimes, right? Look at these examples and see if we can determine explanatory and response variables. A researcher is curious if the number of hours spent doing homework has an effect on the grade the student earns. Well, what was the first thing mentioned? Hours doing homework. And what is the response? The grade on an exam. Okay. Try this one. In a study to determine whether surgery or chemotherapy results in higher survival rates for each certain type of cancer, whether or not the patient survived is one variable, whether they received surgery or chemotherapy is the other. Okay? So, we're trying to decide, did they survive, right? Survive is the response for sure. But then we're trying, it's like they're doing 2 tests. One is with surgery and one is with chemotherapy. So we have two things going on. Explanatory is the treatment. So in this case, it may be surgery or chemotherapy. Okay? But the response is the same. Did they survive? All right? And that's it for 1.3 and 1.4. It's really simple, easy vocab, a little bit more to add to your plate before we wrap up this chapter. All right? We'll see you in class.